Go ahead, start.
So, hello everyone. Here in Move Analytica, we are trying to categorize a high resolution methane mapping in poultry farms. What we are trying to achieve is we are trying to create a scalable and cost efficient way of monitoring the methane from the Canadian poultry farms. So in the past, we have successfully conducted collections of various poultry farms across Canada, and that is what becomes our database to go further in this particular methodology. In this particular aspect, we are using the capabilities of satellite imagery along with artificial intelligence to provide farmers and the other stakeholders, including the government, a benchmarking system to understand the methane emissions from the different poultry farms across Canada. Here, in this particular research, what we are trying to use is the capabilities of Sentinel-2 data, which is freely available satellite data that gives us information within the range of 10 by 10 meter resolution. That hence making it a very cost-effective and scalable option to cover point source emission data. Along with the Sentinel-2 data, what we have seen is that we can use the power of regional optimization to categorize the emissions categorize the emissions from the farms. Now, these emissions can be categorized as low, medium, and high emissions based on the ICC guidelines, which is basically the emission rate along with the herd size, which becomes our approach to understand the emissions. Now, the complete methodology is a cloud-based platform that runs on Google Colab. Hence, we don't have to depend upon the local systems to run this particular aspect of work. Coming to the results that we got through this parameter retrieval is that we can have a range of farm-specific methane emissions expressed in tons per year, ranging. We started our experiment from the year 2020 until 2024. We have collected immense data that we can use in the later part of this work. Also, one particular aspect is that we are also discovering the capabilities of this methodology to provide us emission data with respect to weekly or at least 10 days of at least 10 days interval data. So we are coming up with this emission estimations on monthly basis and weekly basis. So as we see, there is a clear trend in the emission in the last 5 years, with the highest emission recorded in the year 2022. Now, coming to the takeaway from this particular aspect of what we can see that our model is performing at an uncertainty rate between 4 to 6, that is plus 4 to plus 6% of uncertainty. With this uncertainty, what we can expect is we can expect a atmospheric stability model that can account for environmental variability. Also, this particular model provides you a robust error handling since we get data every 10 days. So it becomes very important to acclimatize to that particular aspect. Coming to the future enhancement that we are aiming for is that we are trying to provide a spatial variability account to this particular model, along with the plans of establishing a benchmarking system that will give the stakeholders region as well as farm specific data.